Now, plants regulate a number of factors associated with nutrient uptake, and one of those is absorption capacity. The absorption capacity of a plant is its ability to take up nutrients and the rate it takes up nutrients relative to other nutrients. When we look at differences in absorption capacity among different elements, forms of nutrients, and across plants, we see that absorption capacity often follows demand. It's a little bit difficult to separate cause and effect, but essentially plants can fine-tune their uptake to maintain a relatively balanced ratio of nutrients within the plant relative to the demand by growing tissues. Here's an example that's in the book that shows some of the effects of environmental stresses on the rate of nutrient absorption, in this case by barley. But if you put a plant under nitrogen stress, these plants increase their ability to take up nitrogen from soil solution, and they decrease their ability to take up phosphate and sulfate in solution. So plants become nitrogen stressed, and those individual roots, for example, can crank up their ability to take up nitrogen if it does become available, and downregulate the ability to take up phosphate or sulfate, other elements, which would lead to imbalances in availability within the plant. If you take a look at what happens if you put a plant under phosphorus stress, a parallel pattern exists. They can crank up their ability to increase phosphate uptake, but decrease their ability to take up nitrate or sulfate, for example. And then they have different the author shows an example for sulfur and what happens if you put a plant under water or light stress. But essentially, plants can fine-tune, because nutrient uptake is an active process, they can fine-tune their ability to take up different elements like nitrogen, phosphorus, or sulfur. There's a whole range of different adjustments that plants can do to increase or decrease their ability to take up nutrients, and these are often driven by the relative demand among the different nutrients and for nutrients relative to other resources. But you can see that plants can alter their root to shoot balance. So if nutrients are more limiting, often an individual plant can allocate more of their resources below ground for nutrient acquisition and decrease the allocation above ground for light acquisition. Plants also have the ability for preferential root growth. So if you have areas within the soil that have high nutrient availability, they can localize root production within that zone in the soil to maximize uptake. Lastly, and we covered this, plants can adjust the capacity for uptake. So when a plant becomes stressed, it can increase the capacity for uptake of the most limiting resource. Now I should mention that these are all physiological adjustments that plants can do, and sometimes the evolutionary patterns are opposite of what we see for the physiological adjustments. That's a different story, and it talks about some of the major differences among species and how they go about living in ecosystems where resources are limiting. But it's important to know how individual species can respond to limitation by different nutrients. Now, there are consequences of nutrient absorption that I'll cover briefly here. Nutrient absorption alters the chemical properties of the rhizosphere. There are two ways that this absorption fundamentally alters the rhizosphere. First, and this part is really basic, it reduces the soluble nutrient concentrations. So if you have a root in the soil and you have high concentrations of something like nitrate, plants are going to take up nitrate and reduce the concentration of nitrate in soil. If you take away uptake, for example, by having some kind of disturbance within the system, then we talked about how plants are going to downregulate their ability to take up nutrients if their demand is really decreased. In addition, often a disturbance is going to kill off plants and reduce total potential uptake. And so the concentrations of nitrate in the system stay high. This sets the system up to leach a lot of nitrate into the waterways. And so once you've stopped taking up nutrients, those nutrients can accumulate and then be lost out the bottom of the system. Once you have high nitrate concentrations in soil solution 2, this also makes you prone to patterns of gaseous nitrogen loss that we'll talk about later. So the simple act of taking up nutrients reduces the concentration of those nutrients in soil solution and reduces the potential for loss. The second thing that's important to think about the consequences of nutrient uptake is rhizosphere pH. Now plants take up cations, and when they do that, they have to maintain charge balance. They can do that from one of two ways. So if a plant wants to take up calcium, for example, and bring that into the plant, there's an additional positive charge. It can bring in something that has a negative charge to balance out the positive charge that it just brought in with the calcium or the cation in general. Alternatively, it can balance that charge by secreting protons. If it's not maintaining charge balance by taking up anions to balance out cations, then it has to pump out protons, or else you start to build up charge and it gets even harder to bring in additional cations. The secretion or the loss of protons from the system acidifies the soils. So in order to maintain that charge balance, it's going to release H+, and that's going to drive down pH. So one of the factors that occurs when plants are taking up large amounts of cations is that really can acidify the soil. That's going to change the properties of the soil, for example, and we know that different nutrients are available differentially at different pH levels. All that acid has other effects and can get into the water downstream and have an acidifying effect on downstream ecosystems.